This video we're going to talk about the composition of two or more functions here. Function composition, it's the fifth type of function operation. It is commonly used out in the real world with taxes and discounts and increases in prices. But in a mathematical term, it's also used to help us verify inverse functions and do other problems. So to look at function composition from a generic point of view, if we have two functions, f of x and g of x, okay, and we're looking to compose the function f with g of x or the function g of x with f of x, this is how that's written. It's written f composed with g of x. And that really is the function f evaluated at the function g of x. Okay? Then if we were to compose g of x with f of x, that would look g composed with f of x equals the function g evaluated at f of x. Then we could have some special ones like the function f evaluated at f of x as well. F composed with f of x is the function f evaluated at itself. Okay? It's important to know this circle here. It does not mean, it isn't an O, it isn't a 0. It's a mathematical symbol for two functions that says the composition of two functions. Okay? Alright. Let's look at our first example here. We have the function f of x equals x squared and the function g of x equals 2x plus 3. The first thing that we're looking at to find is the function f evaluated at g, or the composition of the function f and g of x. Remember, if we're taking the composition of two functions f and g, in this case here, because f comes first, we're evaluating the function f at g of x. Alright, so essentially what we're doing here is we're taking our function g of x, which is 2x plus 3, and wherever we see an x in the function f of x, we're going to replace it with an x squared. So f of g of x here is the function f evaluated at 2x plus 3. Well, the function f evaluated at 2x plus 3 is going to be x squared, which is going to be the quantity 2x plus 3 squared. And this term here, when we expand this binomial squared and multiply it like you know how to, that will be 4x squared plus 12x plus 9. And that right there is your answer. That's the function f of g of x. Now if we look at it a little differently here, if we look at the function g evaluated at f of x, that's really the same thing as g of f of x. That's the function g evaluated at f of x. In this case, what we're going to do is, wherever we see an x in g of x, we're going to replace it with x squared. Alright, so we're evaluating the function g at x squared. The function g evaluated at x squared, wherever we see an x in g of x, we're going to replace it with x squared. We get 2 times x squared plus 3, which is really 2x plus 3. And that's your answer right there. Let's look at one more type, a little weirder type. Let's look at the function g of g of x. Okay, that's the function g evaluated at itself. Okay, so if we evaluate g at g of x, wherever we see an x in g of x, we're going to replace it with the same thing. Alright, so if we evaluate g at 2x plus 3, well, we're going to replace this 2x plus 3 with 2x plus 3 because we're composing a function with itself. So we have 2 times, well, if we're evaluating the function g at g, 2x plus 3, we have to replace this x with 2x plus 3. Plus 3. Alright, this here, that's what x is in our original function g of x. Alright, and then when we distribute the 2, we get 4x plus 6 plus 3, which is 4x plus 9. And there's your answer for g of x. Okay. So that's composing two functions at any value of x. All right. The next couple of examples are going to be evaluating these composition of functions at a specified value of x. Right. Here's two final examples here that talk about function composition and evaluating functions, these function compositions at a defined value of x. Right? So our first example here, well, let's look at what our functions are. Our functions f of x are x squared plus 3, and our function g of x is 5x. Okay? Our first example here, or our third example, or fourth example here that we have, says find the function f evaluated at the function g evaluated at 2. Find the function f evaluated at g of 2. There's a couple different ways that we can go about doing this. We could actually find what the composition f of g of x is, if we want to. But there is an easier way, which I'll describe later. Let's look and find what f of g of x is. Alright? Alright? We find f of g of x. Okay? We're going to evaluate f of x at g of x. So, g of x is 5x. The function f is x squared plus 3. So we're going to evaluate wherever we see an x in f of x, we're going to replace it with 5x. So we have 5x squared plus 3. This simplified, taking care of that power, is going to be 25x squared plus 3. And now what we can do is we can go ahead and evaluate this function here, f of g of x, at 2. So f of g of x, f of g of 2 is going to be 25 times 2 squared plus 3, which is 25 times 4 plus 3. 25 times 4 is 100, plus 3 is 103. And that right there is your answer. Right? The function f evaluated at g of 2 is going to be 103. Now the shortcut to this, the shortcut is going to be to evaluate the function g of x at 2. Okay, so shortcut. I'll write shortcut right here. Alright. If we evaluate g at 2, that's going to be 5 times 2, which is 10. Then what we do is we take f of x and we evaluate it at whatever we got for g of 2, which is 10. So we evaluate the function f of x at 10, which is going to be 10 squared plus 3. 10 squared is 100, plus 3 is 103. And look what we have here. We have the same exact answer both ways. So those are both two valid methods to solving this one problem. One might seem a little long and tedious, the other one might seem short and concise. Again, it's whichever method you prefer. All right, and then the last example here, find the function f evaluated at the function f evaluated at -1. That's a -1 there. Alright, so whether you want to do it the long way or you want to do it the short way, it's up to you. I'm going to do it the long way first. I'm going to find f of x. Alright, so if we find f of x, that's going to be f of x squared plus 3. That's going to be x squared plus 3 squared plus 3. When we FOIL this out, we'll get x to the 4th plus 6x squared plus 9 plus 3. And adding the 9 and the 3 gives us x to the 4th plus 6x squared plus 12. Then evaluating this expression here at -1, that's going to be -1 to the 4th plus 6 times -1 squared plus 12. -1 to the 4th power, negative numbers to any even power, is going to be positive. -1 to the 4th is a positive 1. -1 squared is going to be a positive 1, so 6 times positive 1 is a plus 6, plus a 12. 1 plus 6 is 7, plus 12 is 19. Okay, so we have 19 there. Let's see what we get when we do the shortcut. Alright, if we evaluate the function f at -1, -1 squared plus 3. -1 squared is positive 1, plus 3 is 4. And then if we evaluate the function f again, at 4, we get 4 squared plus 3, which is 16 plus 3, which is 19. And we get the same answer in both cases. So 2 methods to solving the same type of problem here. One involves the mathematical way that we discussed earlier in the video. The other discusses the shortcut method. Just evaluating inside the function first instead of doing the actual composition evaluated at x. Again, it's up to you, whichever method you decide to use in that case. Either way, you get the same result. Alright, so that's the video on function composition. Thanks for watching.